This is Unit 1, Lesson 3, Graphing Rational Numbers. We all know that each rational number corresponds to a unique point on the number line. And in this lesson, we're going to be using estimation and equivalent forms to plot the numbers on the number line. Rational numbers. We know those are the set of all numbers that can be expressed as a fraction. They can be positive or negative. They can come in various forms, such as integers, fractions, decimals, and percents. But any rational number can be written either as a terminating or a repeating decimal. That's going to help us out when we go to plot them. Example 1, plot 1/8 on the number line. The trickiest part is determining what the scale of your number line is and figuring out where the number falls within that scale. So if we take a look at this number line, you can see by the tick marks that the space between 0 and 1 is divided up into 4 sections. Therefore, each tick mark is representing 1/4. So we can go ahead and label those tick marks accordingly. We're trying to graph 1/8. So we understand the relationship between fourths and eighths. So we can go ahead and think of those in terms of eighths as well. Now, you can write these numbers down to help you plot, or you can do this in your head. If we want to plot 1/8, we can see that that falls in between 0/8 and 2/8, exactly in between, and so that's where we need to plot the point on the number line. So this doesn't require any more work than figuring out what those tick marks stand for. Now, here's the same thing again, except with a different number line. Here the number line is divided up into different sections, and you can see we go from 0 to 1 with 10 sections in between. So this is divided up into tenths. Well, that's not nearly as straightforward as eighths. So we're going to do something that's going to help us figure out where 1/8 goes on this number line, and that's determining the decimal equivalent. So to do that in this unit, you're going to do it by hand by doing your division. So if we divide 1 divided by 8, you can see it comes out 0.125. So that's what we need to plot. Well, I don't see 0.125 on this number line. It's not quite that specific, so we need to figure out where that falls within the tick marks that are shown here. What I like to do is think about what two it's in between. I know it's a little bit more than 0.1, and it's a little bit less than 0.2. So it helps me to write those above and below the number, and then I can kind of visualize what's going on. So I know it's falling in between the two of those, but the question is where exactly? Which one is it closer to? Is it halfway in between? How do I figure that out? So what I do is I look at the values after the decimal, and really we're comparing 100 and 125 and 200. You can see that 125 is closer to 100 than it is to 200. So I know that 0.125 is closer to 0.1 than it is to 0.2. So when I go to plot it, I'm going to plot it closer to 0.1. Now here's another version, yet another number line, and you can see this one between 0 and 1 is divided up into 3 spots, so this is divided up into thirds. So you can think of those as the decimal equivalent, 0.333 repeating, 0.666 repeating, and rounded off, it comes out to 0.33 and 0.67. So that's an approximation just to give us a sense of what those tick marks stand for. Now, we're looking for 0.125, so we know that's going to fall in terms of those tick marks in between 0 and 0.333, and so you can see my plotted point went up there a little sooner than I intended, but you can see that 0.125 is in between those two values, but it's a little bit closer to 0 than it is to 333, and so we can plot that point a little bit closer to the 0. All right, example 2, I'd like you to try this one, -7/8 on the number line. So you're going to need to figure out the decimal approximation by dividing, and then plot that on the number line. So at this point, go ahead and pause the video, do that work on your note sheet, and start up again the video when you are ready to check your answer. Okay, let's see how you did. Well, I can see that this number line is divided into fourths, just like my first one was. So I know that the numbers on each tick mark correspond to 2/8, 4/8, 6/8, and 8/8. The same in the negative direction, -2, -4, -6, -8/8. So if I want to plot -7/8, I know it's going to fall in between -6/8 and -1, which is -8/8. So I can go ahead and plot it right there on the number line without doing any additional work. If I was unsure, I could go ahead and do the division to get a decimal approximation, and that could help me out as well. All right, example 3. Plot 2/3 on the number line. Here we're going to do the same. We're going to try and figure out what our scale is. You can see that this one is tenths, and then we're going to determine that decimal equivalent. So 2/3 is 0.666 repeating. Now that's one that you might have memorized, so you don't necessarily need to do that division by hand every time. If you recognize 2/3 as 0.66 repeating, that's great. So we need to compare that to what's on the number line, and we've got 6/10 and 7/10, and we know that that's a little bit bigger than 6/10, but it's less than 7/10. We know that it's a little bit closer to 7/10 than 6/10, so I go ahead and plot that in between and a little bit closer to 7/10. Example 4. Plot 83% on the number line. Well, the same as before, we've got to translate that into its decimal approximation. So 83% we know is 0.83 as a decimal, so that's a little bit more than 8/10, so that's going to fall a little bit past 8/10 on the number line. All right, example 5. I've got 6 of them here for you to try. I want you to plot and label each number on the number line. You're going to first find the decimal approximation if necessary, and then go ahead and plot each number. At this point, pause the video and come back to see how you did when you're finished. Make sure you show all your work on your note sheet. All right, let's see how you did. Point A. First thing we need to do is convert to decimal form to help us out. We know that -5/2 is the same as -2.5. That's -2.5. So I can put that point right there at -2.5. Point B is already in decimal form. I know that's in between 0 and 1. Now my tick marks on this number line are fourths, and I can think of that as 0.25, 0.5, and 0.75. So I know 0.82 is a little bit past 0.75, so I'm going to plot that right there in between the 0.75 and the 1 on the number line. Point C is 1/9, and I needed to divide to find my decimal approximation, the decimal form of that. Decimal form is 0.1 repeating. Where's 0.1 repeating fall? Well, it's more than 0, but it's less than 1/4, than 0.25. So that's going to fall pretty close to the 0, but to the right of it. Point D is 1.3. Again, I recognize those tick marks. In between 1 and 2 is 1.25, 1.5, 1.75. So 1.3 is more than 1.25, but less than 1.5. So that's going to fall right there. More than 1.25, pretty close to it. Point E, I'm going to do my decimal approximation, -2.375. So I know that is farther to the left of -2.5. So that's actually less than -2.5. And so it's going to go to the left of the -2.5. And point F is -17% as a decimal approximation. That's -0.17. When I think about where that goes, I know that it's close to -0.25, right? Those are the tick marks on this number line. But it's not quite there, and so it's going to go in between 0 and -0.25. All right. Remember, quick quiz tomorrow at the start of class, and you may use your note sheet, so make sure you put that in your binder right now and bring it with you to class.